Hey guys, so today I'm going to go ahead and continue the lesson 6 notes. We're on, let me see here. We're on page 6, and so if you would go ahead and after watching the lesson 6 day 2 part 1 video, that this is the next one that's going on. Let's take a look at this idea. Yesterday was on distributive properties, so we had combining like terms. We have combining like terms today. We had the property that lets you take a number that's outside parentheses and distribute it into the function. And in this one, after you do some of that math, after you've used the distributive property to get rid of parentheses, now you gotta think about how you're gonna combine things back together. Mathematically, what we're looking at is ways to combine things that have variables, like how there's a 12r in example 1, and then ways to combine just constants, or sometimes you have more than one exponent, like x squared or x to the third, and how that's different from just a single x. Let's do example 1 together. One of the ways to think about this is to break down the idea of what it means to have 12r. 12r literally means that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 r values, and they're all being added together. The other thing is that this minus 8 is like minus 1, 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 minus 1. 6, 7, 8, nailed it. And then the minus 12 means another minus 1, 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 minus 1. So you can't just straight up combine the 12r with the 8 and go, hey, 12 minus 8, that's 4. You can't do that. The 12r refers to how there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. And then the minus 8 and the minus 12 is physically adding or taking away numbers, mathematical things that you can subtract. So looking at the groupings that we have here, there's 12r's, leave that. Leave it as is, 12r. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That should kind of make sense. 8 plus 12 is 20, so negative 8 minus 12 is negative 20. And there's our answer. That's legitimately what you do. You look at things that are considered alike, as in how r is a variable and not a number yet, but it's this object, and the number negative 1, negative 1, negative 1, etc., that's used. I'm going to get rid of all of this. This may not work as well as I like, but I just want to have kind of a clean space. In fact, hooray! Let me rewrite the answer. So we have 12r minus 20. That's the answer to number 1. To continue that idea, no, you don't have to do what I did for this example, but you should think about that in the back of your mind as you make a decision. Do I combine this? Do I combine those two things? And of course, as I'm explaining here and you're like, I think I got it, just go ahead and skip to the next question or just, scrub forward in the video. Just to repeat for a second example, what I did in the first example, let's go to example 2 and reiterate, well, no, you do too, extra practice. Let me do 3. Okay, example 3. So this is kind of a little bit different because we have some negatives and some positives that we're blending together. But I'm going to write this as negative x. So first of all, let me explain. I'm going to take each of these terms. Terms are the things that are separated by plus signs. So 1, 2, 3, 4 terms. I'm going to break them all the way apart, and then I'm going to regroup together. And I'm showing the full break apart only so that I can get to a shortcut, and you know like why the shortcut works. So negative 2x is like negative x and another negative x. And then the plus 11 means plus 1. In fact, I don't even want the plus right there. I'm just going to write 1. And 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10 and 11. Plus 6x. So I wrote a minus sign in front of these x's, and I'm going to kind of get things to line up for a reason. So I have x, 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 and x. 1, 2, 3, 4, 5, 6 of them. Now I'm taking those and lining them up. So I'm kind of doing this like shuffling with the negative 2x and the plus 6x. And then last of all, I've talked about 1, 2, 3 of them. Now I'm going to write the minus 7. So minus 1, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. There are my 7. There are my 7 negatives, my 11 positives. Okay. A negative plus a positive is 0. A negative plus a positive is 0. So if you see something that's negative and looks exactly like something that's positive, they combine and they make nothing. So that means negative x and positive x cancel out. Negative x and positive x cancel out. How many x's are we left with? 1, 2, 3, 4 of them. Continue that idea. A negative and a positive cancel out. So 1, 2, 3, 4, 5, 6, 7 negatives will cancel 1, 2, 3, 4, 5, 6, 7 positives. And I'm left with 1, 2, 3, 4, just the number 4. So this whole expression, number 3, simplifies to 4x plus 4. But you're saying, LeBrant, is there an easier way? And there absolutely is. The easier way, once again, 12r minus 20. That didn't work out the way I wanted it to. And extra practice. Okay, where are you? There you are. Okay, so this one, the easier way is to not necessarily think about you have to always break them apart, but it's just to look at the coefficients, because I expect you to be able to do add and subtract really well. So if I cleverly combine the things that have similar features and put them together and then do the mathematics, that's what I'm looking for. So I'm going to put negative 2x plus 6x. Just put them right next to each other. Put all the x's in the same location. And remember, this was take away an x, take away another x. This was given x, given x, given x, given x, given x, given x, 6 times, right? And then the 11 and the minus 7. Put them together. So plus 11. I'm going to show you something too. I can add negative 7. Remember, subtraction and adding a negative, they do the same thing. So therefore, you can swap them out interchangeably however you need them to be. So I could maybe even rearrange this. But the thing is, I already saw what the answer is. I saw that the answer is 4x plus 4 just by breaking everything out and then cleverly combining things together. So if I break everything out, I guess I can do negative 2 plus 6. And get that answer. That is, take away 2, add 6, the answer is 4. And then because they're numbers that are modifying x, I'm going to make sure that x is a part of that answer. Just combining the numbers that are called coefficients. Coefficients are at the beginning. Then I'm going to take the 11 and the negative 7. I'm going to cleverly combine them. And so 11 and negative 7 is 4, because 11 minus 7 is 4. And therefore, as we distribute, 4x plus 4. Maybe you knew that already. Maybe that's review. I hope it is. If it's not, I wanted to make sure I explained it. So for these other examples as I'm going through, feel free to just let me set up the problem, or not even that. Work through the problem and just scrub through the video until you find where I give an answer for it. With less explanation for number 4, and with you needing to finish the answer out. Here's number 4, start. First of all, 5 is distributed to both terms in the parentheses, distributive property. So 5 times 2 is 10, and because it's 2x, I'm going to add an x. 5 times the other term in that parenthesis, which is a 2, so 5 times 2. Then bring down the plus 3x minus 6. They had no parentheses, and so therefore they just get to stay, and we're good to go. Your job, extra practice, full simplify this. Combine like terms, make sure that everything is in simplest form. Lead with x at the beginning and then the number at the end, like how I did right here. Lead with x and then the number at the end. Put it in that order. Okay, so practice. I'll do one of these. I'll pick that one. Close enough to 4. I was thinking 3, 4. 4 will work. Okay, so you need to do these 3 as extra practice. There we go. There's my E. Extra practice. I'll do number 4, and then you'll work through and you'll show me that you're done. So, because of the parentheses, distribute. So 6 times 3z makes 18z, and 6 times negative 4. 6 times negative 4 is negative 24. Minus 18z and plus 4. I always add that little line in the z because sometimes my numbers look like 2's, and I don't want it to be that way. Okay, 18z cleverly combined with negative 18z. Positive and a negative, they cancel. I'm not even going to write anything down. They're gone. I mean, I lied. If I did write something down, I write 0z down. There, add that slash. It doesn't look like Oz. 18z minus 18z, 0z, but it doesn't necessarily matter. It Don't even bother writing it down. Okay, negative 24 plus 4. So this is the other two things. Negative 24 plus 4. That is, go to the number line to the left to negative 24, and then walk it back 4 spaces. You're winding up with negative 20. So therefore, the answer to number 4, everything that simplifies out, negative 20. Box it. Okay. Go ahead and finish the combine like terms assignments. One comment before you do, and somewhere on the margins over here, it'd be worthwhile putting down x squared plus x. That's as simplified as that gets. There's no way that you're able to say that you have 2 x's, which means x times x, so 2 of them through multiplication, that they're exactly the same as that object. This object of x times x is different than this object, so therefore they just can't be combined. Okay, I'm going to go ahead and scrub to the next page. Please do the learning targets and success criteria. I mean, can you apply the distributive property? Can you combine like terms? Do you know when something that you simplified is actually equal to what you had when you started? Like that keeping things, like there's no like numbers that vanish. They have reasons for vanishing, like this one down here, the 18 and the negative 18. They vanished when they worked together. But they're still there in the problem. So if you look at this right here, I guess there's where that 0z came from. Okay. We like this question a lot. We like this question because of how it's used on the Smarter Balance, but it's also a little different than what's used in the Smarter Balance. So you can kind of think about like, hey, we did this math thinking that we're going to need it. I guess I shouldn't have done that. But thinking like, will you see a question exactly like this? No, you won't, but it'll be close. 5x times 2x, distribute. 5x times negative 11. Remember that minus sign goes with the 11. So 5x times 2x and 5x times negative 11. Whatever you get for your answer when you write it out needs to look like this. And pay attention to that little box up there on the x. There's probably an x squared. Probably. Okay. Make sure you do the problem set. That's homework. That goes with it. If you need help, check with me. Do your Khan Academy, and then call it a day.